We're graphing the cosine of x and his friend, the reciprocal secant. Hey, back again with another video on graphing. So hopefully you watched the first video on graphing the sine and its reciprocal cosecant. Because I'm going to speed this one up a little bit. This video won't be as long because hopefully after that one, this one will be a little more intuitive. So we have the correct unit circle. I'm not going to play any tricks with you this time. We have a list of reciprocals just as a reminder. So let's just get on with it. So when we look at the cosine of x, keep in mind, who are you? CSI. Cosine is the x value. And all I'm going to be doing is really graphing the unit circle, the x values, onto the Cartesian coordinate plane. So at 0 radians, the cosine is equal to 1. At pi divided by 2 radians, the cosine is 0. And then we come around the unit circle. At pi radians, we are again at, back down to -1. Then right here, 3 pi divided by 2, we are at 0. Then back up here at 2 pi, we are at 1. And then if we go up again, we're back down to 0. So this graph is smooth and continuous. And one of its defining characteristics of sine and cosine, well, any trigonometric function that we've got, they repeat. So not only is it just sine and cosine, tangent, cosine, yeah, they repeat. So that's a really cool thing about trig functions. Now let's graph this side, which is no big deal. You're probably saying, well, isn't it just a reflection over the y-axis? Yeah, well, let's just do this. Going this direction, this is negative pi divided by 2 radians. Cosine is 0. And then at negative pi, we were at -1. Then we're here, then back up at -2 pi. So let's just graph this bad boy. And it goes on like that forever. So the domain, once again, sine and cosine, the domain's the same. You can plug in anything. It's all real numbers, all reals. The range, it seems to be trapped, in this case, between -1 and +1. So using interval notation, I'll write it just like that. And just like the sine function, the period here, let's see how long it takes for it to repeat. So it goes from here, goes down, all the way up, 2 pi. And what's interesting is this all students take calculus concept to know which trigonometric function is positive in which quadrant. That actually ties into the period piece. Not a lot of people make that connection, but it really does. Because here, cosine is positive, then it's negative, but then it's positive. Well, wait a minute. Be careful. It's positive, then it's negative, negative, and then it's positive. So to capture all these pieces and all those different positive and negative values, we have to go all the way around the entire unit circle to do it. And keep in mind, this piece right here is this piece right there. Notice how cosine is going from 1 to 0. It goes 1 right here, then it goes what? Square root of 3 over 2, square root of 2 over 2, 1 over 2, then 0. So it gets smaller as it goes that direction, and it gets smaller as it goes here. And then right here, we're negative for cosine, we're negative for cosine, we're still negative for cosine, still negative for cosine, and then right there, and then once we hit back, let's see, make sure that I've got it right. Right here, from 0 to here, we're now positive. So I'm going to do my fingers. Well, let me just do it all over again. Here, and then this piece, and then this piece, and then this piece, positive. We're positive in the fourth quadrant because the x values are positive. We go from 0 to 1, 0 to 1. Pretty cool. So graphing the secant function, which is the cosine's reciprocal, what we're going to do is just use reciprocal values and graph it and see why this thing looks so messed up. It is a soup sandwich. So watch this. The reciprocal of 1, of course, is 1. The reciprocal of -1 is definitely -1. The reciprocal of this 1 right here is, of course, 1. The reciprocal of -1 is -1. The reciprocal of this +1 is +1. Okay, that's not bad. So now what we're going to do is graph some of these zeros. Where the cosine is 0, its reciprocal is undefined, which means we have a vertical asymptote right there. So here's 0, so that means we have a vertical asymptote right there. 0, a vertical asymptote right there. 0, vertical asymptote right there. 0, a vertical asymptote right there. And then just like we did with the sine and the cosecant, watch what I do here. I am increasing, which means this graph is decreasing. I am decreasing, which means this graph is increasing. Reciprocals. So, I mean, if that confuses you a little bit, well, let's look at some numbers that increase. For example, 1/9, 2/9, 3/9, 4/9, 5/9. That's definitely increasing. So we take the reciprocal of all these, which would be 9/1, 9/2, 9/3, 9/4, 9/5. We see that we go from 9 down to 3 to even less than that. So as these increase, their reciprocals will decrease, which is why we're getting this. So this is decreasing. We're going down from left to right, which means this bad boy would go up from left to right. This is increasing, so we're decreasing. Same here, increasing, decreasing, decreasing, increasing. Right here, this is decreasing, so I'm increasing, increasing, I'm decreasing. So you have all these, looks like an infinite number of little parabolas popping up on the secant. I mean, I remember it was 1980 something when I first saw the graph of this in a book. I didn't even have graphing calculators back then. The TI-81 had not yet been given to people like me. And I said, what the heck is this? I had no clue where they got this from, because I didn't know my basic identities either. And I might have known my identities that, that cosine is equal to 1 over secant and secant is equal to 1 over cosine, but I didn't put the two together and what that really means graphically. Well, here you go. Very beautiful. So, if we look at this bad boy, we see that there are lots of restrictions to the domain. Hence, the domain for this function is not all reals. And we also see that our range is very strange because, we don't have any values that are less than 1 or and greater than -1 at the same time. It's very strange, And the period, it does look like the period here, if I were to slide this over, this is -pi/2. And to capture this one, 3pi/2, that's still a period of 2pi. One nice little bookaboo I'll throw at you real quick is if I came up here and said, well, heck, I might just throw a 2 in front of that bad boy. F of x equals 2 times the cosine of x. Does that change my domain? Does it change my range? Does it change my period? Well, every value for cosine we got, we're now multiplying it by 2, which means now we are here. We're still at 0, and we would drop down to -2. So it stretches this graph out so that now my range is -2 to +2. And that's all it does. Doesn't affect the domain a bit, doesn't affect the period a bit. It's interesting, very interesting. And in fact, if I were to come up here and then say, well, what happens if I add 3 to this bad boy? I do the cosine of x, and then I add 3 to it. What will that affect? Well, all it does is takes this graph right here, the original one in black, and slides it up 3 units. So -1 down here will be slid up 3 units to become +2, and the 1 right here will slide up 3 units to become 4. So my range will definitely be affected. It just was a slide upward. So now we can start getting into what happens here if we do 2 times the cosine of x plus 3. That's for another day. I hope you enjoyed this video because all we did was graph cosine of x and his friend the reciprocal.